Today, we will be talking about the comparison test, but more importantly than that, this video will serve as a test as I'm trying out something pretty unique and it took a lot of time and I just want to see how you feel about them. Now, what is this unique thing? Well, it was created by the YouTuber 3Blue1Brown, and it's called Manim, which is essentially a Python library that lets you create really cool and interesting Python animations. And I feel like they're really cool and I feel like I could really improve how I made my videos if I showed them to you. So, without further ado, let's move on to the video and to the new thing that I'm going to show you. Now, what is the comparison test? Well, the comparison test is a test for figuring out whether a series converges or diverges. Now, if you don't know what any of these terms mean, then be sure to watch my last couple of videos, especially the one which is titled The Most Important Question, Part 1, as that covers the most important parts of what you need to know for this video. Now, how does a comparison test work? Well, the comparison test works by essentially comparing two different series. One series, we know whether it converges or diverges, and using that information, we can tell if the other series converges or diverges. Now, without further ado, let me introduce what I've created using Manim and how I can help explain this to you. Let the series, infinite series of an and series adding up all the terms of a function b of n with 0 is less than or equal to a of n is less than or equal to b of n for all terms n. Now, number 1, if b of n converges, then a of n converges. And if a and n diverges, then b and n diverges. Now, this doesn't mean that if a and n converges, then b and n converges. That is not necessary. The converse of these statements are not true, as they normally say in proof logic. Now, let's move on to an example. We have two series. One will be our reference series, from n is equal to 0 to infinity of 1 divided by 2 to the n. This will be our reference series. Our next series will be from n is equal to 0 to infinity of 1 over 2 to the n plus 1. This will be the series that we're trying to test whether it converges or not. Now, if you look at all of the terms in this series, you will realize that 1 by 2 to the n will have the terms 1, 1 by 2, and so on. And the 2 to the n plus 1 will have 1 by 2, and so on and so on. And how does this work? Well, 1 is greater than 1 by 2, 1 by 2 is greater than 1 by 3, 1 by 4 is greater than 1 by 5, and so on and so on. And by our first rule that we said earlier about the comparison test and how it works, that means 1 over 2 to the n plus 1 converges. Our next series involves two series. Number 1, the one that goes from n is equal to 1 to infinity of 1 by n. This is the harmonic series, and it diverges. The next is n is equal to 2 to infinity of 1 over n minus 1. And this will be our test series. Now, if you look at all the terms, you see that 1 is greater than 1 by 2, and 1 by 2 is greater than 1 by 3, 1 by 3 is greater than 4, and so on. And sorry, over here it should be n is equal to 3 to infinity, not 2 to infinity. Sorry. Now, this is a very good because all of the terms match precisely to the formula that we said earlier. But what if it doesn't? What if for some terms in the series it's greater than versus just always being less than or greater than or whatever it is. But for some terms, what if it doesn't follow the pattern? That's the main question we're trying to answer. Over here, we have two series. Number 1, the series from n is equal to 1 to infinity of n plus 3 over n cubed. Now, this is our test series. The second series is our reference series of n is equal to 1 to infinity of 2 over n squared. Now, if you notice, over here, for some of the n's, you have that the first series is greater than the second series. But as you notice, it's only for a finite amount of terms. So that sum will be some quantity, we can call it m or x, whatever, some small quantity greater than the actual series. But from n is equal to 2 onwards, as you can see, all of it works perfectly. From n is equal to 3 onwards, all of it goes directly into the series, and the rest of it works. And what we know is that it's very, very simple that this series converges due to the p-series rule. And since the test series is less than that for pretty much every single term besides the first couple, that means it's going to converge to some finite value, which will be slightly greater than the reference term, but that's not very important. All we mostly care about is, does the series converge or diverge? So, what did we learn? Well, we learned that for the comparison test, for two series, a to the n and b to the n, one of them will converge, not always, but b to the n. This shows that if there is a concept of a series being less than or greater than another series. Now, it might have felt obvious because some series converge and diverge, but this really solidifies it, literally using the fact that a series is less than another to prove something immensely fundamental about the series. The next is, what even is the comparison test? We learned the comparison test. And the final major thing we learned is that it doesn't have to work for every term, because that's why so many things have limits as n approaches infinity, because as long as there is pretty much an infinite number of terms, as long as a finite amount of terms don't work, it's fine, because infinitely more terms do work, essentially canceling out any possible effect that happens on the rest of the series. So that's really about it for today, and thank you so much. I also hope you enjoyed the animations I created. I will work on making them better and better in the future. This was just a test video to see how the algorithm reacts and how you react. So once again, thank you so much. See you in the next one, and bye-bye.